Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 5 of Linux Zero to Hero series, and in this episode, let's explore process management, monitoring, networking, and disk management. Overall, we will learn section 7, 8, 9, and 10 of our Linux course. Of course, there are so many concepts, but most of these concepts are interconnected. Also, I'm going to share a lot of useful resources in the video. So make sure you watch it till the end. First things first, let's start with process management. So what exactly is a process on a Linux server? A process is a running instance of any program. For example, you are running a Python application on a Linux server. Now this running Python application is a process. Or maybe you're running a shell command or a shell script. While executing, it is also a process on a Linux server. Or even a web server or application server while running is also a process on the Linux server. So overall, process is a running instance of a program. In episode 1, I explained you that software applications or programs cannot directly interact with hardware. That is, they cannot directly consume underlying CPU, memory, or file system. There is an intermediate layer which is called as operating system. So what an operating system does? It performs CPU management, or it performs CPU scheduling, it performs memory management, file system management, and network management. However, while the operating system does this, however, if one of your process, let's say, is CPU intensive, or one of your process is memory intensive, then this process is going to utilize most of your hardware resources. Let's take a simple example. So imagine you have this hardware, or you have a virtual machine or a Linux server with just one CPU. Just for example, and you are trying to run a Python program, a cron job, and a web server. The Python application written by the developer is CPU intensive, something like a ML model, let's say, or something related to AI. Quite obviously, there are a lot of calculations in that case. So when this particular process goes to the operating system tries to schedule this process with CPU, and as it gets scheduled with the CPU, it is going to take a lot of CPU's time, because more number of calculations, CPU is going to take more amount of time. Only when this process goes to the wait state, once the calculations are complete, it goes to the wait state and other process gets allocated with the CPU or scheduled with the CPU. But if this process is taking more amount of CPU's time, so it is spending more time with CPU, indirectly or directly, it is utilizing most of the CPU. Let's say it is utilizing 90% of the CPU. Then rest of the processes are only left with 10%. And let's say web server is utilizing 10% of the CPU. Quite obviously, your shell script or your cron job, whatever you are trying to run, is left with no CPU resources. It can be same case with memory as well. In fact, any hardware resource. If you take memory, your Java application, assume, is memory intensive. Abhishek, can you give an example? Yeah, very simple. Your Java application, let's say, has multiple threads. Of course, as a Linux administrator or DevOps engineer, you might not deal with Java applications, but imagine a developer wrote a Java application, and this Java application has a lot of threads. So it is taking a lot of time with hardware, and it is utilizing 90% of the memory. Again, same example, 10% of memory is left. When your web server goes to get the memory, it might receive out of memory error, right? Or your web server might return out of memory error in the logs. Now, in such cases, what you need to do? So, as an administrator or as someone who is dealing with the processes or the Linux server, you need to perform three activities. One, you might need to view the processes or maybe understand the processes that are running on the Linux server. Two, at times you need to kill certain processes. In the same example, right? Imagine there is a Java application and it is trying to utilize 100% of the CPU. And imagine your Linux server is almost hung, right? Or your Linux server is hanged. So what you need to do? You definitely need to kill this process. Otherwise, other processes cannot execute on it, or even other people might not even log into the Linux server. Typically, on a Linux server, you will find hundreds of processes that are running. If you take a production instance, you might see more number of processes as well. So if you don't kill this process, all the other processes might not work. So in such cases, you also have to kill the processes, or maybe you have to stop the process. After a while, you might have to resume the process once everything is settled down. And at times, you also need to prioritize or deprioritize the processes. So CPU has an algorithm. There is no point going into the depth of that algorithm, but CPU has algorithm with which it decides the priority of the process. Of course, it is related to the time a process spends with the CPU. But for now, just understand CPU decides priority of the processes. Let's say there are three processes. CPU decides which process is more priority, which process is little less priority, and which process is the least priority. This can be understood as doctor and the patients. Let's say there are a lot of patients. All patients are important. However, for a doctor, patients in ICU are more important. So patient might spend more time with this particular patient. So doctor is prioritizing the patient in the ICU. Similarly, if a process, in our case, a Python process, is spending more time with the CPU, that means CPU prioritizes that process. CPU assumes this process is very important, right? So at times you need to tell CPU, hey, please don't consider this process as priority. You can just deprioritize it and focus on the other processes. Perfect. So as a Linux administrator, you need to perform these activities. One, view or check the running processes. Kill, stop or resume processes. Prioritize or deprioritize the processes. And this particular activity is called as process management, right? You don't have a lot of control on how CPU deals with the processes, but as a user or as an administrator, you can perform the following activities. So let's see step by step. First, how to view or check the running processes. We can take our Linux container environment. In the previous classes, we learned how to create a Linux container environment, whether you're on Windows or Mac OS. If you're not aware, you can check the first episode of this series. However, on a Linux container environment, you will not find a lot of running processes. Why? Because this is not actual Linux server, or this is not even a virtual machine. This is a concised version of a Linux server. That's why when I run PS, you will find very less processes on this server. But Abhishek, I want to understand more number of processes, or I want to deal with more number of processes. Just take a cloud instance of a Linux server. So I'll just connect to an EC2 instance. You can connect to Azure VM, or you can connect to Google Cloud Platform, virtual machine. Anything is the same. Cool. Now that we are connected, I will first switch user to root. How can I do that? Sudo su hyphen. Now I am at the root user. And to check the list of running processes, the command that I can use is ps. So ps will list the process. However, it does not list all the processes. To list all the processes, you need to run ps hyphen aux. My bad, ps aux. So you can see literally there are a lot of processes running on this server. For example, this is the systemd process, right? One of the system related daemon process. You can find the k worker process. You can find multipath D process or multipath daemon, right? So many Linux processes that are running on it. Along with some Linux commands that we have executed, I just switch user to root. This is also a command, kind of a shell command. So because of that, it is also a process that ran. So it is showing the process that is running. Cool. Now, Abhishek, can I check how many processes are running? Yeah, it is also one of your activity. At times you need to check the count or the number of running process. What you can simply do, ps aux pipe. What does pipe do? Pipe takes output of your first command and forwards that to the second command. So there is a command in Linux which is called nl. Nl is the line number. So when I execute this, you will see along with the output in the first column, you will find the number of the lines. So this is 109 line number. So overall, there are 109 processes running on this Linux server at this point of time. There is also another way of dealing with it. Instead of line number, you can just do wc-l, which is word count. So you will see the same output. It is only printing the first column, which is telling us the number of lines. 109 lines, that means 109 processes. Okay, so we learned how to check processes, how to check all processes running on this server. Then we learned about ps aux hyphen pipe nl as well as wc hyphen l. Okay, all these commands are great. Now, is there any other way of checking processes? This is an interview question where usually interviewers ask you, what is the difference between ps aux and ps-ef? Because when I run ps-ef, it is also showing the list of running processes. And if I do ps-ef pipe nl, you see the same output. There are 109 running processes. You can find it with ps-ef and you can also find it with ps-aux. Right? This is ps-aux. The only difference is that when you run ps-aux, you can understand that better on the terminal because there are less number of processes. If I do ps-aux, you will see the process ID. Along with that, process ID can be seen in ps-ef also. Along with that, you will find CPU utilization and memory utilization. Whereas when I do ps-ef, you will not find CPU utilization and memory utilization. So this is the important difference between ps-aux and ps-ef. ps-aux shows you the memory utilization, but ps-ef does not show you the memory utilization. It shows you the CPU utilization, but not memory. So when you want more output related to the process, you go for ps-aux. Okay, perfect. Now we learned how to view the process and how to check the process. Let's just understand output of each column here. What does user mean? User is the one which initiated the process, or user is the one who triggered the process. In this case, root is the user that triggered bin bash, or if we go to the Linux instance, root is the user that is running this C group related process. So the first column says user. And also you will find some with Ubuntu, some with QE user, whichever user triggered the process. Second is the process ID. Every process has a unique process ID because the user might be same, right? Root user can trigger 100 processes, but you need to have a unique process ID so that you can call this process with this PID. If you want, you can kill the process using PID, and you can manage the process using this unique identity. So PID is a unique identity for the process. You know what is CPU utilization, what is memory utilization. Ignore these things for now, TTY as well. Then you will find the start time of the process and also the command. That is, with which command the process has started. For example, if you see Nginx process, you might find a Nginx command. Or when you see a Python process, you will see the Python command that started the application, right? These things are enough related to viewing or checking the process. Now, how do you kill a process? Right? We will start with kill, then we explore stop and resume. How do you kill a process? It's very simple. First of all, why do you kill a process? Let's understand that. So what happens is that at times there are some process, as we learned here, the Java process, it might hang the complete Linux file system or the complete Linux server. So such process need to be killed so that other processes get the CPU or memory. In nutshell, there can be some applications when you work as a DevOps engineer or Linux administrator, that applications might hang the entire system. During that times, you need to kill that process. You already learned how to find the process ID. Now, to kill a process is very simple. Just use the command kill followed by the PID of the process. Let's say I want to delete this particular thing. So Q user started a process called bash. So to kill that, you just need the PID of the process 4055, copy paste 4055. That's it. The process is killed, right? So to kill a process, first thing you view or check the process and then you kill the process. In real time, you might get a requirement like on a Jira ticket or you might get it on the email. Can you find the Java application process that is running on the server and kill the process? So what will you do in that case? First, you will run psaux. Let's run it on this instance. So you will just run psaux pipe grep. Grep is a command to filter the output, right? Imagine there is a file and in that file, you are finding a particular word and then you are printing the line of the word. That is exactly what grep command does, right? So psaux pipe grep followed by you will just do Java. This is not a Java process that is running on it. So you just ran this command. So the output is basically this command is also a process, right? So the one that you are seeing is basically this command itself. When you see one line, you can imagine that there is no Java process running on this server. If there was a Java process running on this server, you will find a process ID, right? You can just take that process ID and run kill followed by the process ID. If this was the process ID name 33292, and this would kill the Java process. Again, I'm repeating, when you run psaux followed by grep and a particular process name that you're looking for, by default, you will get one line, which is nothing but the command that you executed. The command that you executed is also a process. That's why you will see one line. Don't confuse that with the actual Java process that is running. If you don't want to get confused, you can just use this command psaux pipe grep. Let's say you're grepping for Java. Do that. Followed by pipe grep -v grep. I keep using this because what this will do, this will not print that line. So grep -v is to remove that or ignore the line with the grep word. Okay, anyways, so there is no Java process running on it. That's why I did not, it did not return anything. If there was a Java process, you will find the process ID. Then just use kill followed by the ID of the process. Okay, great. We learned how to kill the process. What if one of the process, you know, in this case, let's say you have this process, right? QE and the process ID is 4040. If I just try to do kill 4040, okay, it said the process is killed. But if I again do ps-aux, you will still find the process with 4040. That means the process is not getting removed. In such cases, you can forcefully kill the process. For example, kill -9 4040. Now this time, if I do ps-aux, you will not find that process with 4040 process ID. So what does kill -9 do? Again, this is an interview question. What is the difference between kill and kill -9? Kill -9 is forcefully deleting the process. Perfect. So you also understood how to forcefully delete the process and how to delete the process. Within kill command, there is also another important thing, right? So we were talking about process here, right? So imagine there is a Java process, and this Java process is taking a lot of memory, or it is consuming a lot of memory. So your developer might ask you, Abhishek, can you share the thread dumps for the process? So basically, all the threads or all the internal sub processes of your Java application, they are asking the logs. In such cases, you can use the kill command. Instead of kill -9, which will kill the process, you can just use kill -3, right? So kill -3 is to get the thread dumps, especially for Java applications. Kill -9 is to forcefully kill the process, and kill is to just kill the process. If it doesn't get killed, you will use kill -9. Okay. Now, sometimes you don't want to kill the process. You want to temporarily stop the process. After a while, once things settle down, you might want to start the process, right? In such cases, you can use this command. Let's do ps-aux, and let's say I want to temporarily stop this particular process. So I can just do kill -stop followed by 4048. Now what does this do? You will still find that process called 4048, but the process is temporarily stopped. Whenever you want to resume the process, you can simply do kill -cont, that is continue, followed by 4048. And this process will just resume, right? So this is how you can stop the process and you can resume the process. Till now, we have learned how to view and check the process, how to kill, stop, resume the process. Next, we will learn how to prioritize and deprioritize the process. At any point of time, if you want to get these commands that I'm using, just go to this GitHub repository. I don't see a lot of people starring the repository. It's going to be very useful in future when you want a quick reference. So just star the repo, you will get the information. Go to episode 7 in the process management, go to readme, you will find all the commands that I am using here. In fact, you will find a lot more commands as well, right? Some of them which I might not cover here, you can go back and you can find that as part of the process management document. So make sure you use these notes as a revision material. Okay, so we learned how to stop the process as well, how to continue, resume the process. Now let's see how to prioritize and deprioritize the process. So for that, there is a command in Linux, which is renize. Okay, so renize is a command where you can specify, for example, renice hyphen n 10 hyphen p 4048. Now, what will this do? Okay, anyways, it says you cannot set priority for this process because it's not an application that is running. It's just a command that we executed, right? So this was a command that was already executed. That's why it is saying you cannot set priority for this particular process. But let's say when you're dealing with a Java application that is running or a Python program that is running, you can simply deprioritize, or you can lessen the priority of the process using renice command hyphen n 10 minus p 4048. The important point here is hyphen n 10. What does that mean? So whenever you set hyphen n, let's say 10, so it starts with minus 19 to 20. So when you set a less number, that means the priority is more at the CPU. When you set a higher number, the priority is less at the CPU, right? For example, when you set minus 18, that means the process gets a very high priority. When you set plus 18, the process gets a very less priority with the CPU. So using these numbers, you can actually set the priority at the CPU, right? And the command for that is renice. So renice hyphen n 10 hyphen p followed by the process ID is going to less the priority of a process. Similarly, renice hyphen n, let's say minus 5 hyphen p PID is going to make this process important process for the CPU. I already explained why is it needed. By default, the algorithm of the CPU thinks whichever process spends more time with the CPU, it is important process, just like doctor and the patient. Doctor always thinks patient in the ICU is very important. Similarly, CPU. But when you want to say CPU that, hey, I know it is taking a lot of resources from you, but I want to tell you as an administrator, this process is not that important. Then you will use the renice command, right? And you need to be very careful while using these commands. You cannot just use it. You need to have very strong understanding of what are all process running on your Linux server. So a star mark while using these process, that be extra careful. Only if you are aware what all the process are running on that Linux server, or only if you own that Linux server, use these commands. Perfect. You can try these commands on the EC2 server. Just run a Python program, or use the existing process and try to use these commands and see what happens. Of course, it's a sandbox environment, so if anything breaks at the Linux instance, you don't have to worry. It doesn't break, but it increases and decreases the process of the priority of the process. Okay, cool. So we learned everything that we discussed here. However, there is another important concept related to the process, that is special processes on the Linux server, which are called as services, right? It's not completely different from process, but services are background running process, right? Services are background process which starts at the boot of the server. Imagine if your server goes down, your Linux server went down. The Python application that you're running will obviously go down and it doesn't automatically start. Whereas services are special kind of process which runs in background, and when your server goes down, maybe during the restart of your process of your server, these processes, services come up automatically. Best example is your laptop. Let's say you're watching YouTube on your laptop, on your browser, and automatically for some reason, maybe the battery is dead, or a software upgrade, your laptop restarted. Will your YouTube application come up automatically? Mostly no, right? So they are basically process. But even when your laptop goes down, some of the process on your laptop automatically come up. Such kind of things are called as services. Especially in the Linux world, this is very, very evitable, okay, or clearly visible. Now, which one are the process that Linux administrators or DevOps engineers use in the day-to-day life, and which one are the services? Best example is the application. So Python application, Java application, shell script, these are all the process. But services are things like your web server. Best example is your web server. So you can initially create your web server as a process, but you can convert the web server as a service. These days, most of the web servers like Apache, Nginx, they already, the install script that they provide, they already make sure that the web server is running as a service, so that if the Linux server stops, next time when the Linux server comes up, their web server is running automatically. It's important, right? Because web server sometimes hosts static content, right? As an application developer or Linux administrator, you might write a script that once your machine is restarted, just start the application. But these web server providers or applications providers, they are just starting their application or their product as a service, so that whenever your system goes down, it automatically starts. So best example is your web service, which is provided as a service by the installation script. Now, how can you list services? Okay, we learned how to list the process, but is there a way to list the services that are running? For that, the command that you can use is systemctl. So systemctl, as the name says, you are controlling the systems. So a utility for managing your systems. You can just do list units. All these commands are available in the document. You don't have to worry. You will find them in the README file. Hyphen hyphen type is equals to service. So when you run this, you will find all the processes that are run, all the services that are running on this Linux machine. So there is one modem manager that is running. There is a keyboard shortcut that is a service that is running. There is a cron service that is running, cloud init, because this is AWS instance, right? So you have all of these services running. Let's say you want to stop one of these service. What you can do, of course, we don't have a web server here, but I'll just stop the cron service. I might not have access to it, but let's just try systemctl stop followed by cron service. Perfect. It stopped. When I do list, right? This time I cannot see the cron service. I can simply start it, right? So to start it, just change the stop command to start. Now, when I do this, I should find cron. Perfect. So I can see the cron command. So what exactly we learned? Just like process, we learned how to start, how to stop, and how to check the services. The only difference between process and service, just I'm repeating it, if it is asked in your interview, services are special kind of process, and services start at this time of booting of your server. Whenever your server restarts, service starts automatically. Whereas it's not the same with the process. Can you change a process to a service? Yes, you can do that. But these days, most of the installation scripts like web servers, application servers, they are already providing it and they are starting their applications as services. Perfect. So this is about process management. And I would recommend you to go through the README file, because there are some additional commands such as how to run a process in the background, Very simple commands, right? Just few simple commands that I've added to this document. How to run process in the background, how to run process in the foreground, how to check background process. Those are the commands which are added to this document. Perfect. So I hope you enjoyed this section of process management. We will move to the next section, that is monitoring. So we will learn what are the common things that a DevOps engineer or administrator monitors on a Linux system. As I told you, this is very much related to process management. In process management, we learned about process, and what we do as part of monitoring is we try to check which processes are consuming more CPU, which processes are consuming more memory, and which process are consuming more disk, or which files are consuming more disk. How can we do that? Using PS AUX, you can check all the process, but usually there are a lot of process, right? There can be 1,000 process as well. So going to each line and understanding using PS AUX is not that easy. So are there any commands that's going to help administrators understand the top processes in terms of CPU, or top process which are consuming more amount of memory? For sure. So we will learn top process, and we'll also learn how to check CPU and memory on the Linux system. So let's take the EC2 instance again, right? So there is a command to monitor everything like your system, CPU, memory. The command is top. So top is a very important command. When you run this, so you will see the process ID and the exact amount of CPU and memory utilized by the process real time. If you're doing PSAUX, it doesn't show you the real time data. Whereas this one keeps updating real time. So you can just take a tab, or you can create a dashboard using the top command, and it keeps updating every second. For example, previously the memory utilization by this process was 1.4, and immediately it changed to 0.6. So you can perform real-time monitoring using the top command. It shows you CPU utilization, it shows you memory utilization as well. So the first command that you do, and it also lists in the order. So the top ones, you will find it at the starting, and the least consuming process, you will find at the bottom. If there is a Java process that is taking 100% of the CPU, you will instantly find that in the line number 1. So you can just copy it and you can go for the troubleshooting of that process. Okay, so top is definitely useful. Then you have just an add-on to top, which is called as htop. So htop is basically a wrapper on top of your top process. It might not be available on this Linux instance. Oh, fortunately, it is already there. So what it is doing, it is just providing same information with more beautiful user interface or better representation, right? So here you can actually see this particular graph, which is showing you that 1.2% of your total CPU is utilized, total number of tasks that are you're running, right? What is the uptime of this machine? That is from how many days this machine is up, and everything that is changing in more color format. The only difference between top and htop, so htop is visually better than top. That's it. It gives you almost same information. Okay. Then you also have this command called vmstat. So what vmstat does is that it reports the system performance. At time as a DevOps engineer, someone might complain you that, hey, this particular Linux instance is very slow, or this particular Linux instance is not performing well. So you can use vmstat and you can check what is the free memory that is available on this instance, and is there huge amount of caching. With that, you can debug the instance and understand if this instance is in good shape or not. Usually you need to check if there is lot of free memory or not. If there is a lot of free memory, then there is no problem. Okay. You can also find the same information instead of VM stat. If you only need memory information, just do free hyphen m and it is going to show you the free memory and the memory that is already used. But Abhishek, I can find that information using top command as well. Thing is that top is a very good command, but it cannot be used in your scripts. Let's say you are a DevOps engineer and you are writing a simple health monitoring of virtual machine script. You cannot use the top in that script because it's a visual representation. Whereas when you run free hyphen m, it is giving you the static output. You can just perform some grep on it, or you can just perform awk or SED on it, and you can get the exact field that you need. With top, it's not that possible, right? And you can also use free in human readable format. So instead of this one that you might not understand more, if you want to get the output in MBs, so it says total there is 557 MB of memory on this machine, which is close to 1 GB, out of which 360 MB is utilized and 220 MB is left. Rest is used for caching, right? Rest memory is used in cache. Perfect. So we learned about top, we learned about htop, we learned about vmstat, and we learned about free. I would recommend using free in -h, which is human readable format. But Abhishek, how do I check CPU? Like how many CPUs that this virtual machine has? Just use the command nproc. So nproc will give you the amount of CPU that is available on this machine. It just has one CPU, and top command exactly tells you the CPU utilization of this machine. Or htop provides exact utilization at this point of time. Cool. How can I check this space? For CPU, I'm using nproc. For memory, I'm using free. Similarly, is there a command which tells me what is the current disk utilization on this particular virtual machine? Because these are three important pieces of hardware. What are three important pieces of your hardware? CPU, memory, and disk. For CPU, we are using nproc and htop. For memory, we are using htop and free -h. Now, how can I check disk space? So for disk space, you will use this command called df-h. On your file system, there will be a lot of partitions. So your file system of 8 GB or 20 GB will not be a single partition. There will be multiple drives or there will be multiple partitions. So you will find for each partition. So this is your primary partition, which has 16 GB, out of which 16 GB is utilized. That is 3% of it is utilized out of 744 GB. Similarly, you have various partitions out of which it tells you how much is utilized. But the important one is the slash file system, which is your root of file system. And it has a lot of disk that is left. So you can typically create so many files on it and still you will not see any issues with the disk space. Abhishek, can I see folder by folder? Okay, I can understand from disk point of view, but it is very difficult to understand which folders are in this particular file system, which folders are in this particular file system. Yeah. So what you can do is you can just run du-sh. Let's go to a particular folder so that we can do it better. Let's say I go to OPT. Here when I run du-sh, any number of folders that are within /opt, you will see the utilization, disutilization of each folder. This way you can find if there is any large files in a particular folder. Imagine within OPT, I create a folder called logs. I create a folder called scripts. and I create a folder called, let's say, Python. Now, when I run du-sh, it will star. It will exactly tell me what is the utilization of logs. For now, it's empty. That's why it's 4 KB. This is also empty. This is also empty. And this is also empty. In case there is a file within logs. So within logs, I will create a file, test.txt, test. And here I'll write some content, for example, right? So I wrote some random content. Now, if I do du-sh star, you will see the size of logs is changed. That means out of all the folders, logs is the folder with more amount of disk utilization. This way I can debug which folders has the log files and which log files has lot of log written it. In case somebody complains that there are no resources on this file system, I can simply go to that folders and delete the logs. So the command for disk utilization, df-h or du-sh star. So these are the commands for the disk utilization. So this way you can monitor your CPU, you can monitor your memory, and you can monitor your disk space. Again, I've added a lot of commands to the README file. So you can just go through the README file and understand more about the monitoring part. These days, we also connect Linux environment with Prometheus. We connect Linux environment with Grafana, where we can get more CPU or memory related information. Or even in AWS, you can integrate that with CloudWatch and you can get a lot of metrics. So utilization or usage of these commands has significantly gone down. For a quick troubleshooting, these commands can be used, but a better way of doing it is integrating your Linux server with monitoring tools like Prometheus and Grafana. I already explained how to do that in our Observability Zero to Hero playlist. I'll also put that link in the description. Or you can just search for Observability Zero to Hero and look for Prometheus Grafana videos. Perfect. So in your interview, if someone asks you for quick troubleshooting, I will use these commands. For CPU, these commands, memory, these commands, and for disk, these commands. Whereas as a DevOps engineer, I have also integrated my Linux server with Prometheus and Grafana so that I can get more real-time information. By configuring alerts, I can send emails when something goes wrong. So this is your actual approach. I can explain the Prometheus part in just 30 seconds. So you might have a Linux server. So what you can do, you can connect this Linux server to Prometheus, where Prometheus scrapes the metrics of the Linux environment using node exporter, let's say, right? And once it gets this information or using the Linux metrics exporter, once it gets this information, it puts that information in Grafana. In Grafana, you can create dashboards which can send alerts such as email notification or Slack notification to the development team or SRE team, whoever is responsible. So this is one workflow that you can explain in the organization as well. For quick Linux troubleshooting, the commands which I explained will help. So this is about section 8, which is monitoring. Now the next section is section 9, that is networking. Networking is super important part of your entire Linux, because as administrator or as DevOps engineer, developer, SRE, whichever role that you are in software engineering, networking plays very important role, whether it's for debugging, troubleshooting, understanding latency, right? Networking is basis for everything. So what I have done for you, I have created a networking playlist. So if you go to our YouTube channel and you will find networking fundamentals playlist, where I've created almost 3 hours content on networking. So just go to this networking fundamentals and you will find me explaining right from what is IP address. You might not find such detailed tutorial anywhere because I explained right from what is IP address, what is subnet, what is private subnet, public subnet, what is CIDR, and the complete OSI model with examples. Instead of repeating the same content, which will take another 2 hours or another 3 hours, what I'm going to do within the description and also in the GitHub repository, I will put the links of the networking fundamentals playlist. Once you learn this, if you want to understand networking in more detail, you can go to our AWS playlist and Azure playlist, where you will find networking concepts related to the cloud as well. However, I would highly encourage you to first go through the networking fundamentals playlist. Then you can go through the AWS networking or Azure networking later when you learn those concepts. For now, go through the networking fundamentals playlist. Again, I'm repeating, you will learn all the concepts right from IP address, CIDR, subnets, then the OSI model, examples of OSI model practically. Instead of just repeating the same thing, I will put the links in the description, right? Or I could easily copy those same videos and put it here, but only the length of video will increase. So this is about the networking section. I'm not repeating the concepts again, but I will put the useful resources link. Now let's explore the next section, that is disk management. Just like process management and networking, disk management is also a common task of administrators, where administrators might add storage, add volume, remove storage. Let's try to understand this with a real life example. Imagine you're managing a Linux instance. It can be a cloud instance or on-premises instance. Initially, you set up this instance with a storage or volume. For example, this EC2 instance here is set up with a volume of 8 GB. So you can see the volume size is 8 GB. Initially, this might be good, but as applications keep running on this EC2 instance, imagine there are 5 applications running on this instance. Each application, every second, every minute, keep adding the logs. For example, info logs, debug logs, some applications log, audit log, right? While they are in KBs, but because they keep adding every second, every minute, eventually this is going to be of huge size. What some companies do is every day they try to zip this or create a archive, compress it, and store it on the same instance. Even when you do that, maybe after 3 months or maybe after 6 months, you will run out of the storage. Now, not only applications, you install other softwares on the instance, right? You install more packages. So eventually you will run out of the storage. In such cases, either you have to take backup of these logs or remove these logs by putting it somewhere else, or you need to increase the storage. Because storage is not that expensive, usually companies prefer adding more storage to critical instances. Now let's see how to add such instance or how to add volume to the existing instances. You can see here my instance size is 8 GB. Let's try to add more 10 GB to it and see how to format and also how to mount it to the instance. Now, what does that mean? Very simple. By default, when you add a storage, let's say I create a new storage of 10 GB. If I just create a storage and add it to the instance or attach that to the instance, it doesn't work. You need to mount it to location like /mnt or any specific location on your Linux instance. Only then the applications or any other programs can use that particular storage. Also, by default, the volume that you create is of type block storage. But your applications or programs cannot directly use the block storage. You also need to format the volume that you create to something more common like ext4 or xfs. We will also understand these steps, right? Very simple. By default, when you create a storage, you can attach that storage to the instance, but applications cannot use that storage because the storage that is created is of type block storage. For applications to use it, or even for you to use it, you need to format the storage to something more understandable like ext4 or xfs. For this, you don't have to do much. You just have to run a single command. Okay. So before we go ahead and perform the demo, let's see some important commands for looking at volumes that are available on the instance, looking at the partitions on the instance, so that you will be more familiar while we perform the demo. So we know now that this EC2 instance is attached with a volume size of 8 GB. How we can see that, right? In the previous lectures, we learned about uh, df-h or du-sh, but can you see the volume that is added, or can you see the storage that is added directly? I will first connect to this instance and show you how you can do that. So df-h or du-sh, they mostly focus on file systems and show you storage that is utilized, used by a particular folder. But now we will look at a command called lsblk. So what does lsblk do? It lists the blocks that are attached to the instance. You can ignore these blocks, whatever starts with loop, because they are not real disks, they are virtual disks that are used by the EC2 instance, typically for the snapshot or the ISO images. So you can ignore these, but your focus should be on this one, XVDA, which is 8 GB. This is just name XVDA, but what's important is you added a disk of 8 GB where the disk is partitioned into 4 different parts, or the disk is split into 4 different partitions. On root, it is 7 GB. So you created a 8 GB disk, right? You created a 8 GB volume. Out of this 8 GB volume, 7 GB is on the root of the file system. For example, if you do ls-ltr/, so you will see all these folders, right? This is on the root of the file system. You can also verify that if you do df-h/, you will notice the size of the root file system is 7 GB. Then Abhishek, where did 1 GB more go? Again, if you do lsblk, you will notice you have other partitions like xvda14, xvda15, which is used by the boot. So if you remember episode 2, where we learned about the folder structure, /boot has images that are used by the EC2 instance during the time of boot, typically during the time of restart or shutdown start. So this is where other 1 GB is utilized. So the root of the file system just has 7 GB, not 8 GB. You can also understand this in detail if you use a command called fdisk-l. Sudo fdisk-l. So fdisk-l usually gives you more information compared to lsblk. They are exactly same commands. I mean, the output that they return is similar, but fdisk-l provides you more details at the file system level or at the partition level. So you can find more information how this partition is split logically, physically. You can understand from IO size point of view, which might not be that important as a Linux administrator when you're managing cloud instances. But if you're managing your on-premises instances, this information might be needed. Okay, so both fdisk-l and lsblk are similar, just that fdisk-l provides you more information about the partitions. So what are partitions? Partitions are nothing but you created a volume. Volume is of type block storage, and that block storage, instead of 8 GB on a whole, is divided into partitions. And each partition can be formatted and mounted to a particular location, right? I'll just repeat this again. So by default, when you create a storage on AWS, it is EBS, which is Elastic Block Storage. So you got this block storage. Instead of using this 8 GB and mounting it to a particular location on Linux operating system, you will split this into partitions. You will format each partition, something like ext4 or xfs, and mount that on folders like slash, on folders like slash boot, etc. Perfect. Now let's go ahead and add volume to the instance. For that, first I need to go to EBS or volumes, Elastic Block Storage, the default storage of AWS, create volume. One important thing that you need to note, my EC2 instance, if I just scroll to the sidewards, is in the availability zone US East 1C. So my volume should also be in the same data center. So what is 1A, 1B, 1C? They are basically data centers. Only then you can attach the volume to the instance. So create volume. Let's just create 10 GB, which is good enough. If you want, you can add a tag. I'll add name later. Create volume. It shouldn't take much time. But one thing, remember, you need to make sure that the volume that you create is in the same availability zone as your EC2 instance. Okay, looks like I forgot. I created it in 1A. Let me quickly delete this. That would have been a big mess. So it is 1C. Create volume. Okay, it says volume is successfully created. The volume state has to be available. Perfect. The volume state is available and status check is also okay. Click on the actions, attach volume. Now in the drop down, you should see the instance. If you don't see, it's not in the same availability zone. That's it. Device name, let's select it as, let's say, SDF. So you can basically select a different one as well, but XDF is more as a common notation. Attach volume. Okay. So this volume, yeah, you should see the volume status as in use. If you don't see this, or if it's in a different state, please wait while this converts to the in use state. And remember, we used XDF, SDF. Okay, now let's go to the instance. And if I do lsblk, so you will see xvdf 10 GB storage. Perfect. Apart from this xvda, which was 8 GB, you have now one more thing, which is of 10 GB. Can I use this 10 GB? Please note this, you cannot directly use this 10 GB at this point because of two reasons. One is it is of block storage. Second, you haven't mounted this yet. Block storage, you cannot use it. Only you have to split this into partitions, format it to a particular file system, and only then you can use it. Even if you don't divide this to partitions, it's okay, but you need to format it. Okay, so we just have the instance at this point of time, or volume at this point of time. Now what I'm going to do is I'm going to format this particular thing, or let's create a directory first so that we can later mount it. mkdir -p /mnt, which is a temporary mount directory. and let me call this as demo volume. Okay, I'll switch user to root, just copy and paste it. ls-ltr/mnt. Okay, so I have the demo thing as well. Now mkfs. mkfs is a command that is used to make the file system -t ext4. As I told you, there are two important file system formats. One is ext4 or the other one is xfs. Okay, mkfs -t ext4. What are we trying to format? /dev/xvdf, right? So this is what we are trying to format. Okay, so it says file system, writing super blocks. Perfect. So the format is also done. Now we can simply use the mount command. Mount, what are we trying to mount? /dev/xvdf on which location? /mnt demo volume. Okay, so now I have mounted this. Now let's see if I run lsblk. Cool. So I have formatted this in the ext4 format and I mounted this in this particular location. Now I'll go to this location, cd/mnt/demo volume, and let's see if I can create a file. Touch. I'll try to create something like Abhishek, just a dummy file, ls. Perfect. So this is how you can add storage to your instance. If you do df-h, now you will see. So you have 9.8 GB, out of which only 1% is utilized. And on your root of your file system, you have 4.4 GB left. So previously it was only 4 GB. Now I have 14 GB size left on the instance. This is how you can add volume. Instead of using this location, you can use a location where your applications write the volume to, right? So if your application is writing volume to, let's say /mnt/logs, so you can just mount the new volume to this location. Perfect. So this is how you can perform disk management. The important commands that we learned: mount, which is used to mount a particular file system. Umount, I did not show you umount, but it is exactly opposite where you want to remove a mount. So previously I added a volume to the mount /mnt/demo users. Using umount, you can remove this. We learned about lsblk, which is to list the blocks. We learned about fdisk-l, which is for formatting. We also learned about mkfs, which is for make file system or to format a block storage or to format a partition. So I hope you enjoyed disk management, and my request is to go through networking zero to hero playlist, and I will also add shell scripting playlist. So overall, in this particular Linux zero to hero playlist, you will find 5 episodes related to Linux zero to hero. Then you will find 2 episodes related to networking zero to hero, and you will find 4 or 5 shell scripting videos. By the time this video is uploaded, you will see Linux zero to hero series will have all of them. So if you follow all of them, people keep asking, Abhishek, how much Linux is important? If you complete all of this, shell scripting videos of mine, networking zero to hero, and this 5 episodes of Linux zero to hero, you don't have to learn anything about Linux. Only this is more than enough. Because when it comes to cloud, I also covered cloud networking in AWS, Azure. So this fundamentals is 100% enough for your interviews. I hope you enjoyed this series. Thank you so much. See you all in the next video. Take care. Bye bye.